Hello, this is a video about OPPO, Optional Parameter Plan Optimization, a feature that Microsoft introduced in SQL Server 2025, allegedly to fix issues with optional parameters resulting in bad parameter sniffing. I say allegedly because I am not happy with how the feature is implemented. Keep watching and you will find out exactly why I am not enthusiastic about this feature. So if you think back of the first video about bad parameter sniffing, I identified 3 common root causes for bad parameter sniffing. Equality predicates on columns with skewed data distribution. Those were addressed kind of in SQL Server 2022 with parameter sensitive plan optimization, PSPO. I talked about that in the previous video where you learned that yes, it helps a bit in some cases, but it's not good enough. But at least it does something. The second common root cause for bad parameter sniffing is an inequality predicate with varying selectivity. For now, that is still something you have to fix. And then the third common root cause for bad parameter sniffing, procedures with all those optional parameters. And this is where Microsoft Marketing wants us to believe that optional parameter plan optimization, OPPO for short, is the golden answer to all your worries. It's not. We'll see why. So let's look at how OPPO is implemented. And OPPO uses the same multi-plan infrastructure that was introduced in SQL Server 2022 for PSPO. So we still have regular queries, and regular queries, those are the queries that do not qualify for PSPO or for OPPO. Those queries are still, as they always were, you have a query and that query is tied to an execution plan. That execution plan is stored in the plan cache so that it can be reused later, and if something invalidates that entry, then it is recompiled and you can get a new execution plan. But there will never be more than one execution plan for the same query in the plan cache at the same time. The query store has a history of all execution plans that at one time were the valid execution plan for that query. So here you can see over time which plans were used. This is all how it has been since the introduction of the query store, and for the plan cache since even before that. The multi-plan infrastructure introduces a new option for queries that qualify for this multi-plan infrastructure. The query is now tied to a dispatcher plan. That is a special type of execution plan. That dispatcher plan is still stored in the plan cache. It is still recompiled after restart, invalidation, memory pressure, blah blah blah, and it is still stored in the query store with your full history. In the graphical interface of the query store, they are hidden, but if you use queries, you can find the dispatcher plans that are stored in the query store. Now, this dispatcher plan is not a real execution plan. It pretends to be an execution plan, but it is not the final execution plan. So that is the next step. Every query is still tied to one dispatcher plan at a time, but that dispatcher plan can then point to multiple execution plans. Each of those execution plans is also stored in the plan cache, recompiled when needed, and stored in the query store where it is kept over time. So you can again see the history. But it all becomes a bit more complex because a query goes to a dispatcher plan and that dispatcher plan then goes to multiple execution plans. This enables the feature to use different plans for different cases, which is frankly what we want, but it also can make troubleshooting a bit harder because the whole architecture is a bit more complex. So what is a dispatcher plan? A dispatcher plan is basically a container for one or more special properties, and in SQL Server 2022, those properties could only be the parameter sensitive predicate property. And every parameter sensitive predicate property had 4 subproperties: predicate, statistics info, low boundary and high boundary, which resulted in up to 3 variants per predicate. I talked about that in the previous video. I'm not going to repeat it. What is new in SQL Server 2025? That now a dispatcher plan can also hold a different type of property called the optional parameter predicate. This also is a property with subproperties, or rather with one subproperty, predicate. The predicate subproperty always has the form @parameter is null. And that means that for each predicate there are two variants. Either the parameter is null or the parameter is not null. It's two variants, but with multiple predicates you can of course still get more variants. In SQL Server 2022, when we only had parameter sensitive predicates, the maximum number was set at 3. In SQL Server 2025, now that optional predicates are added, the maximum is still 3. I will get back to this. But let's first jump into the demo and see all this in action. So I'm going to make sure that there is no plan in cache, and normally you would not clear the procedure cache manually, but I do that in this case because I want to simulate what happens if something causes an execution plan to be evicted from the plan cache. So I have a rather simple stored procedure called find simple that has 3 parameters that are all optional. If I stand here and I type, you can see that salesperson ID, customer territory ID and customer last name are the 3 parameters I can supply. All of them have a default of null, and this is the standard flexible search. I want to find all sales by salesperson ID 290 to someone with last name Martin, regardless of the customer of the territory. Or I want to find all sales to customers in territory 7, regardless of the salesperson or the customer last name, and so on. Here I give them all, and so on. And in this case I specify nothing, so I simply get all the this annoys me even more. Now it's correct. Here we get all the sales. So let's execute these 5 and then look at the execution plans to see what happens. The first execution plan for the first query does have a dispatcher predicate, and that dispatcher predicate has 3 optional parameters. I will expand it all and then zoom in, and there you will see there's a predicate for customer territory is null, for salesperson ID is null, and for customer last name is null. So each of those 3 results in true or false. That results in 1 or 2 plus 0 or 2 plus 0 or 4 to come to the query variant. And for this first call with salesperson ID 290, customer last name Martin and customer territory null, the query variant then comes to 5. That means that this is compiled when the query executes. So the query is submitted, and the first thing SQL Server does is, I don't have an execution plan for this, I need to create it. Step 2, do I qualify for PSPO or OPPO? Yes. Step 3, create a dispatcher plan. That's what we just saw. Management Studio basically gives an integral view of the dispatcher plan plus the finally chosen execution plan. So those dispatcher expressions that I just showed, that is the dispatcher plan. This specific execution plan is for query variant 5. This will always be used if the salesperson ID and customer last name parameters are specified, but the customer territory is not specified. This is of course the first execution, so SQL Server compiles it, which is done with the regular parameter sniffing, so it will sniff the parameters to come up with the best possible execution plan and then execute it with the same parameters in this case. The second query is for customer territory ID 7. We already find the dispatcher plan in the query in the procedure cache. So no new dispatcher plan needs to be compiled, and this dispatcher will be the same. If I execute it all, you will see that it is exactly the same. But the query variant is now 4, because in this case only the territory has been specified and none of the other two parameters. That results in query variant 4. We don't have an execution plan for query variant 4 yet, so this query is now compiled for these parameters, which results in a different execution plan. If I scroll back up, you will see the shape of the execution plan is different. This is optimal for searches based on customer territory only. The third query specifies all three parameters. And we get yet another shape that looks the same as the previous one. In the details there may or may not be differences. The most important difference here is that now we have query variant 1, for all three are specified. And then the fourth query, where I left everything default, return everything, no exceptions, nothing to search for. We get yet a different execution plan, this time for query variant 8. So far we have had 4 executions and 4 compilations, because all of these were not in the procedure cache yet. But this is not the same as option recompile, because option recompile would do 1 compilation per execution. And yes, so far we did that as well. But this 5th sample call has the same parameters set or not set as the 3rd. They are different values, but it's still the same query variant. So if I look here, you will see that the query variant is 1. We have seen query variant 1 before, so now no new plan is compiled. The existing plan is reused, and we can see that by looking at the parameters. All of them have a compile time value for the first call, and now the runtime value is different. This means we can get other parameter sniffing issues here if these are skewed predicates, but I'll get back to that later. The optionality of the parameter is now handled in a great way. If all possible combinations are used by my users, then over time 8 execution plans will land in the procedure cache, and that's it. They will remain in the cache as long as they're valid and there's no memory pressure. There will be no more recompilations, and for every possible combination of set or not set parameters, we get an execution plan that is optimized for that combination. We will not use an index seek on salesperson ID if salesperson ID is null, because that index seek wouldn't do anything. Before OPPO, that could happen. So far it all looks good. And this is the kind of demo that Microsoft Marketing wants me to give, because this makes this look like a good feature. And for this specific case, it is a good feature. So this is some preparation for a later demo. I am now going to go to a different store procedure, find orders. And this store procedure, let me just show you, has a total of 1, 2, 3, 4, 5, 6, 7 store procedures, parameters. All of these are optional. Trust me, I created that store procedure. All 7 are optional. So this is a more realistic kind of flexible search. In practice, most databases that use those flexible search procedures don't stop at 3. I see a bad typo here. Don't stop at 3 optional parameters. Most have more. The OPPO feature still uses the multi-plan infrastructure with up to 3 predicates. So if there are 7 optional parameters, the optimizer has to choose which 3 get chosen. Now for PSPO, that could also be the case. You could have queries with 4 equality predicates on skewed data distributions. And if all 4 were sufficiently skewed, as explained in the last video, the 3 with the highest skewness are chosen. So that is documented. If there are more than 3 optional predicate parameters, then there is no documentation on how the optimizer chooses which 3 become the optional parameter predicates in the multi-plan infrastructure, in the dispatcher plan. So let's just run this batch as an example. And in the first execution, this is on a clear procedure cache, so nothing is in the cache when I start. And oh wait, this is not smart. Let's do it in 2 parts. Clear the cache and then run this batch on a clear cache. There is nothing in the cache yet, so we first need to create a dispatcher plan. That dispatcher plan now has to do this selection of which maximum 3 parameters are used to choose the dispatcher expressions. And I can see here when I expand the dispatcher that there is actually only 1. The optimizer decided that sales order ID is null is a relevant difference to make for different execution plans. So we're going to get 2 execution plans. In this case, the sales order ID was set, 51,721. So we get query variant ID 1. That doesn't exist yet in the procedure cache, so the execution plan you see on the screen now is compiled based on the sniffed value 51,721. That should probably execute quite well. And indeed, if I look at the statistics I/O, you see that all the numbers of logical reads are single-digit numbers. This is a very efficient execution plan. Then we executed find orders again with a new set of parameters. SQL Server looked in the plan cache and found a dispatcher plan. So the existing dispatcher plan is reused. That means we only look at whether sales order ID is null or not. Sales order ID is null, so SQL Server will now look at query variant ID 2. That query variant ID doesn't exist in the plan cache yet. SQL Server creates the execution plan optimized for 276.943 van der Kamp. The result, this is a bit less efficient because these are more generic searches. We also get more rows back, but the numbers of logical reads are still pretty low and we are not unhappy with this performance. Then SQL Server executed the third call. And again, the dispatcher plan is there, sales order ID is null, query variant 2. Let's go to the third execution plan. We will see that the same execution plan for query variant ID 2 is used. Now this is not a new compile. This was compiled when the second execution ran. So if you look in the parameter list, you will see that in this case the execution plan is compiled for salesperson ID 276, but it runs for salesperson null. We might have bad performance because of this. Perhaps it's not that bad in this case, but all those 7 parameters, well, 3 of them are different. Van der Kamp remains the same, so that might save us. Let's look in the statistics I/O. And indeed, you will see that for this third execution, we also have relatively low values for the logical reads. However, I happen to know that customer ID is an indexed column. That might have been faster. But we reused an execution plan that didn't search for customer ID. However, in this case, I'm going to say that the price is not that bad. So far it looks good. But the fourth execution now looks at give me all the orders for product ID 943. SQL Server looks in the plan cache and says, hey, I find an existing dispatcher plan. I should look at whether sales order ID is null. Sales order ID is null, query variant 2. I have an execution plan for that as well. And we once more execute the same execution plan that was optimized for salesperson ID, product ID, and customer last name. But now we search by product only. And now we see that the choice for a dispatcher plan for only sales order ID actually hurts a lot. There are some extremely expensive table accesses here. And on a realistically sized database, this would be noticeably slow. So why has SQL Server decided to create a dispatcher plan for only sales order ID? It has the ability to use 3 optional parameters. I mean, there are 7 optional parameters in the stored procedure, so 3 is still a bit limited. But why choose 1? And why that one? Well, perhaps it is because on that first call, sales order ID was the one that was passed in. So let's just reverse the order. So I'm going to clear the cache, pretend that something happened that kicked everything out of the plan cache. And then I'm going to execute the same 4 statements, but in a different order, plus 1 extra that is needed for the next part of the demo. So let's execute them. And you already notice that this batch is taking quite a while. I need to find something to talk about just while we wait until the entire batch has finished executing. And there we are. Something was very slow. Now in this case, what was actually slow was that we had to wait 13 seconds for the memory grant, which is a bit weird, but I guess with the recording software and everything, there's a bit limited memory on my laptop right now. But let's look at the statistics I/O and stuff like that in a bit. So what happened now is there's no dispatcher plan. I just kicked it out of the procedure cache. So SQL Server has to create the dispatcher plan. My theory, based on the previous block, where the first call had a sales order ID, now we have a product ID. So my theory would be, again, a dispatcher plan with 1 optional predicate for product ID. Well, there are 3 optional parameter predicates. The maximum is used. Which 3? Product ID, sorry, product ID is not even there. Customer last name, order month, and sales order ID. Why does SQL Server choose these 3? Frankly, I don't know. It is not documented. There is no predictability here. So of course, this search based on product ID now is reasonably fast. I mean, 3-digit numbers, it's not the best, but we do a very broad search. What do you expect? And let's look. This execution plan actually had query variant 8. The second execution, let's move to the second execution plan, has a different query variant 4. The third one, then, let me see if I created this right, yes, has also query variant 4. There are different parameters passed in, but there is no difference with regards to the 3 predicates that were designated to be the optional predicates. So query 2 and 3 use the same plan. So in the statistics I/O, the first query, like I said, good enough. The second query optimized for the sniffed values, and then the third query reuses the previous execution plan that was not optimal for these parameters, and you get bad performance again because OPPO doesn't fix everything. There are way more optional parameters than 3. SQL Server has to pick 3. The others are still hurting us because they can still cause bad performance issues, bad parameter sniffing. The fourth execution plan then is a different query variant. So this gives good performance again. And the fifth query is, I think, yet another query variant. Yes, query variant 1. So these both will be reasonable performance, because remember, they are new execution plans. SQL Server sniffs the parameters, and will give you an execution plan optimized for that. But these execution plans can all be reused by later calls, where any of the 4 parameters that are not chosen to be optional parameter predicates, if they flip between null and not null, you will get bad performance. Now, how does this look in the query store? And if I go online, let's begin with this query. So this is a query where I select for something in the query text that I have just used, and if I run this query, what you will see is that there is a query ID 5 that has 2 plans, and all others are query IDs that have just a single plan each. This one was never executed. It isn't a procedure, which is nice, that we know that, but it's never executed. These were executed, but we lost the information that they are in a procedure find orders. So what happens here is that query 5 has now 2 execution plans. Those are 2 dispatcher plans, and these are the actual execution plans that run after being selected by the dispatcher plan. And you can see that I forgot one column in the query, but there is a column that indicates whether a query is a whether an execution plan is a dispatcher plan or not. I'm not sure why I didn't include that in the query. I'm not going to search for it while recording. So I will put in the name of the column in an edit bubble above my head, where it says this is the column that you should add to the query. What you also can do is look at the query text, and unless it's too long because it's at the right side, here you can see these are the optional queries, and here something is added that if you add it to the query it will cause an error, but this specifies, this option plan per value specifies, okay, this is an execution plan that isn't tied to query directly, but to a dispatcher plan. Now there are 2 that each have query variant 1. They are tied to different dispatcher plans, because as you saw, at one point we had a dispatcher plan, then that was evicted from the plan cache, and then we got a different dispatcher plan. And now we have 2 queries, both of query variant ID 1, but they're not for the same set of parameters. They are very different, and this makes it very complex. In this query there is no straightforward way to see, oh, this dispatcher belongs to this one or to this one, and this dispatcher then belongs to that one or that one. Perhaps you can make it, but the problem I ran into, it is stored. You can find this information, so you could join this query store query variant to the query above, but if you do that, then all the regular queries that do not exist in query store query variant go out, unless you do outer joins, and then it becomes more complex. Well, I will leave that as your homework. Let's move on. I already mentioned most stored procedures that use optional parameters in practice use more than 3. The maximum number of predicates is 3. This is a severe limitation. It means that some optional parameter predicates are not recognized as such and will still cause bad parameter sniffing. So it doesn't fix the issue, only for some cases, but not for all. And you saw this instability where what is in the dispatcher plan can change, and then you get multiple dispatcher plans in the query store. You still have only one dispatcher plan in the plan cache at a time, but at a different time you can get a different dispatcher plan, which can result in completely new patterns of unpredictable bad behavior that you never saw before. So this maximum of 3 predicates is overall. So let's return to the demo from the second video on PSPO, where I had a demo table with skewed columns. And if I leave this out, then I have the demo from the previous video where this was recognized as a parameter sensitive predicate, and we needed different plans for low, medium and high number of rows matching the @b parameter. Now it becomes more interesting because now it is an optional predicate on a skewed column. Let's look at the execution plan to see what the optimizer makes of this. We do get a dispatcher, and you see that there is both a parameter sensitive predicate and an optional predicate. So they work both, which is good. But that also means that we already used 2 of the available slots. So let's look at a different example, and again, if I delete this, this is what I showed in the previous video. And here SQL Server will recognize there are 2 parameter sensitive predicates. But now there are 2 parameter sensitive predicates that are both optional. What will the optimizer do? Well, we get a dispatcher, and it uses all 3 slots. And let me expand and then zoom in. What you see is a parameter sensitive predicate for C, a parameter sensitive predicate for B, and an optional predicate for C. But we don't have room for the optional predicate on B anymore. Why are these 3 chosen? Again, this is not documented. I don't know. You don't know. Hardly anyone knows. But what I do know is that in this case I called it with D and A. If the dispatcher plan is ever evicted from cache and then the first call happens to be with 2 nulls, then a different choice is made. Now we once more have a dispatcher that uses 3 expressions, but now it says C and B optional, those are relevant enough, and B is skewed, but yeah, sorry, C is also skewed, but no room for that anymore. So once more we have this instability in the dispatcher plans. Okay, so you're starting to see why I'm not happy with OPPO. I don't like that it's still limited to 3 predicates. That was okay for PSPO, okay-ish, but for OPPO we really need more. I'm very sad and upset actually that the dispatcher plans are this unstable, because this introduces new problems. I will get back to this later, but first let me show you one more thing where Microsoft dropped the ball. So far I have always used, let's return here, always used the form parameter is column or column is parameter or parameter is null. That is the form that Microsoft had in mind when they designed OPPO. But that is not how all my customers handle their optional parameters. When I get called in by a customer, I often see stored procedures that use column equals is null parameter column or column equals coalesce parameter column. Now, some people say this should not be used because it returns incorrect results on a nullable column. I have a few things to say back to that. First, many columns are not nullable, or sad but true, they are nullable but do not contain nulls. In that case, this code is just as valid as the explicit parameter is null or column is parameter. Second, the problem with this on a nullable column is that if you pass in null for the parameter @b, you don't get everything that is null. That's probably not wanted anyway, but you also don't get everything. You get everything with a non-null value of b. Because for rows where b is null, this translates to null, this translates to null, but null is never equal to null. So that is the problem with this version. But what if this is the desired outcome? What if leaving it empty means give me everything where this is filled? It might not be the most predictable and common use case, but it might happen. But third of all, the most relevant, correct or not, this is actually used. I think I see this form more than this form in practice, in reality. But this form is covered by Microsoft, and this form, well, let's just look. For the is null, no dispatcher. For the coalesce, no dispatcher. So these forms, not only are they not recognized as optional parameters, SQL Server now also no longer realizes that B is a skewed column and that we might benefit from the older SQL Server 2022 PSPO stuff. So this is, in my opinion, a major omission. So this is bad. Let's move on to the next example, where I look at something that appears to be an optional parameter, but it isn't. So in this case, because column B is nullable, when I pass in add B as null, I actually want SQL Server to return all the columns, all the rows where B is null. If I pass in D, I want to return all the columns where B is D, and so on. But if I pass in null, I don't want everything. I want all the rows where B is null. You can achieve that in this way. Or if you are SQL Server 2022 and up, you could even use where B is not distinct from. That is new syntax that was introduced in SQL Server 2022. Basically says not distinct from is the same as equal, except that nulls are now also considered not distinct from other nulls. They're not equal, but they are distinct, not distinct. So let's look at these two execution plans. And like I said, in this case, it looks like an optional predicate, but it really isn't. In this case, it doesn't even look like an optional predicate. What does SQL Server do with it? There is a dispatcher, but it's only for the parameter sensitivity. So in this case, the optimizer correctly realized that this B is null test is not related to this being an optional parameter. And it correctly identifies B as a skewed column. For the second query, which uses is not distinct from, we get the same dispatcher with only the parameter sensitivity. In fact, if you look in the details, you will see that the seek predicates here specify B equals at B, and this equals, you have to go to the execution plan XML to see that this is a different equals from the regular equals. So in the XML, it can use EQ, or it can use is, and those have the different meanings for nulls. That already existed before SQL Server 2022, but Management Studio doesn't properly display that. So this equals is not the regular equals, this is the is not distinct. The first execution plan actually uses the same thing. So this means that SQL Server recognizes that this is the same as this, and that is also why it doesn't think that the B is an optional parameter. Now, if we have this nullable column and we want all the null rows returned if we pass in null, but we also want a way to say I do not want to filter on column B, then we have to choose a different magic value. The magic value that indicates don't filter on this column. Normally we use null if null is actual value in the data that we want to filter on, we have to use a different column, a different value. And in this case, I have chosen to use the X, which does not exist in the demo table, and a query where B is not distinct from, shorter form, or B is X. So if B is X, then we return everything. Will SQL Server recognize this as an optional predicate? The answer is there is a dispatcher, but it only recognizes the parameter sensitivity. So what we saw, this is handled as it should. It is not recognized as optional because it isn't optional. This is not recognized as optional. Frankly, I didn't really expect it to, because this is quite uncommon, but it can happen. And often people use magic values like -1 or December 31, 9,999, etc. Empty string, all those things are sometimes used as a magic value to indicate I don't want to filter on this parameter. OPPO does not recognize those as optional parameters. But for me, the biggest thing, the way that many procedures in practice implement optional parameters is null and coalesced are not recognized by OPPO. That was a long demo. Let's wrap up this talk by going once more over all the problems we encountered in the demo, all the things that are wrong with OPPO in the current implementation. I think this is the most important one. 3 dispatcher expressions is simply not enough. I would say that you need at least 10 optional parameter expressions in addition to the existing parameter sensitive. So either you use different maximums, 10 plus 3, or you throw them all together and say a maximum of 13 or perhaps 15 to make it a round number. Then you are getting to the place where it is, for most cases, fairly useful. This is also what bothers me really very much. The unpredictability of which dispatcher expressions get chosen. We saw that if there are more than 3 optional parameters, the optimizer picks 3 of them, or sometimes less, but it's impossible to predict which ones, which results in a new type of bad parameter sniffing issue. Now we have to deal with queries that over time use multiple different dispatcher plans. That's a new problem we didn't have to face before. I mean, if your query changes, or if there are indexes added or dropped, or if there are significant changes in statistics, those are cases where I would understand that the optimizer chooses a new set of dispatcher expressions. I mean, the statistics only play a role in PSPO, and there we know what role they play. Indexes should, in my opinion, play an important role in choosing the dispatcher expressions, because they have far more effect on the possible execution plans than unindexed columns. As far as I know, the optimizer does not take that into account. The query is of course obvious, but these 3 ingredients, query, schema and statistics, those are fair game. If there are significant changes there, I am okay with getting a new dispatcher plan that is better for that new query, the new schema and the new statistics. But what I really do not want to see is dispatcher expressions that depend on whatever happens to be passed in on the first call. Because that is exactly the bad sniffing issues that we're trying to fix. And now we're introducing new bad parameter sniffing. Do not look at the parameters passed in on the first call when choosing the dispatcher expressions. That would be my feedback to Microsoft to make this feature better for use, because I am sort of okay with just picking 3 optional parameters and running with that and accepting that the other parameters can still cause issues. Then, like PSPO, it's a feature that does something but far from enough. But this instability changes it to a feature that actively makes my life worse. I don't like that. Also, in the rare cases that on SQL Server 2022 PSPO actually worked for you, you run the risk of a regression if you upgrade to SQL Server 2025. Imagine you have a query with 3 parameter sensitive predicates. The optimizer recognizes them, they are all 3 parameter sensitive, multi-plan infrastructure is used, and your life got somewhat better. Sufficiently better that you decided I can leave this query as is, the worst problems are fixed, it is now good enough, and I'm not going to do more work on this query. Cool. And then you upgrade to SQL Server 2025, and now the optimizer looks at the same query and says, oh, 3 parameter sensitive predicates, but there's also 1 optional predicate. Let's create different plans for those optional predicates, and now we only have different plans for 2 of the 3 skewed columns, and you might get your terrible performance back because the 1 column that is no longer used in the dispatcher is the one that you actually needed the most. Until a new dispatcher plan is created and things are different again, but I already addressed that. So if you upgrade from SQL Server 2022 to SQL Server 2025, you might lose 1 or more parameter sensitive predicate expressions in existing queries because now optional parameter predicate expressions are added and the maximum is still 3. I don't think an upgrade should ever have a regression risk like this. This is a foreseeable risk. This should not be possible, in my opinion. And like I showed in the last part of the demo, some very common methods for handling optional parameters are simply not even recognized by OPPO, which means it's simply falling short of what it should do. And not recognizing other magic values than null is something I can kind of forgive Microsoft for, but not recognizing coalesce and is null is, in my opinion, a major shortcoming of this feature, in addition to all the other shortcomings. So where on SQL Server 2022 my recommendation was PSPO is on by default on new databases, just leave it on. It's not going to hurt you. It might even help you in some rare cases, but even if it doesn't, it's not in the way. On SQL Server 2025, my recommendation would be, leave a parameter sensitive plan optimization on with the same explanation, but turn optional parameter plan optimization off. This feature is actively making your life worse. So I would only enable it on databases and for queries where I have tested, have verified, and have seen that in that specific case OPPO does more good than bad. That is when I would enable it, because it's still a feature that does things, and I had an example where it worked perfectly because I set up that example to specifically show the ideal happy case. But that can happen in your system. It's not a feature that's always bad. It's usually bad. But when it's not bad for you, enable it. If you're not sure, leave it disabled until you can test it. That is my recommendation.
And that's it. That was OPPO for you. I hope you liked this video. I hope it was useful for you. If so, click the thumb to leave a like. If you have any questions or if you would like to leave feedback, just leave a comment. I try to respond whenever I see it. And of course, if you want to get a notification when my next video goes live, click the subscribe button and you will always be informed. My name is Hugo Cornelis and I thank you for your attention. Goodbye.